Good morning, everyone. My name is Zizhen, and I'm from Tokyo Metropolitan University. I would like to share my paper, Translation of New Named Entities from English to Chinese. Introduction. As new things are being created and new words are constantly being added to language worldwide, translating them into different language is a considerable task because it is not practical to translate them all manually, especially translating from an alphabetic language such as English to Chinese. Appropriate Chinese characters must be assigned, which leads costly compared to other language pairs. So we propose the task of generating and evaluating new translations from English to Chinese, focus on the named entities. Considering general NE translation, the same as criteria of text translation, the translation should be natural in the target language as well as has the same meaning as the source language. Besides, English to Chinese NE translation should also consider the Chinese characters Hanzi selecting, because one thing could be represented by several Hanzi combinations. Thus, to evaluate the English to Chinese NE translations, we defined three criteria for human evaluation considering naturalness and correctness with Hanzi selecting. Fluency denotes how natural is the translation in Chinese. Adequacy of pronunciation and meaning denotes the correctness of transliteration and literal translation, respectively, which are translation methods in NE translation. The most common method for NE translation is transliteration. It uses Hanzi that's phonemes similar to the source language. For example, Blackstone is transliterated to 百事通, Springfield is transliterated to 斯普林菲尔德, and IKEA is transliterated to 一家. In this case, the adequacy of pronunciation is suitable for evaluating the correctness. Also, some NE are literally translated. Morphemes that have similar meaning with source language will be used. For example, the Blackstone group could also be translated to 黑石集团, where 黑 means black, 石 means stone, and 集团 means group. In this case, the adequacy of meaning is suitable for evaluating the correctness. Not only the translation method is used in NE translation, the hybrid method is considering both transliteration and literal translation. We must give consideration to the correctness of both pronunciation and meaning. In the example, Semperos Cathedral, Semperos is transliterated to 圣保罗, and cathedral is literally translated. Related work. Chen et al. Present a proper name translation mechanism for the information retrieval system. They focused on the person name translation from Chinese to English, and formulated a person name translation problem as a phonics string matching problem. They consider the length of matching characters, syllables, different romanization systems, and pronunciation rules to rank candidates' translations. Finally, they integrated the translation mechanism into a Chinese-English information retrieval system. Wang and Vesper presented an algorithm for the transliteration of English place name to Chinese. They used semantic abstraction, uh, syllabifications, and subsyllable divisions to simplify the place name and divide them into syllables, then map them to fixed Hanzi. To evaluate NE translations in three criteria manually, we choose NEs in the domain of company name, which includes enough amount of parallel data with all translation methods. We construct our evaluation data based on the company list of the New York Stock Exchange, and here's some examples shown in Figure 1, in which we select the companies that have both English and Chinese Wikipedia pages as a source and target NEs respectively, shown in Figure 2. And because we focus on the NE to Chinese translation, companies from Greater China are ignored. In all, 338 English-Chinese NE pairs were evaluated by two annotators in terms of the three criteria mentioned above. Now I would like to introduce the detail of criteria and annotation. In the fluency dimension, fluency measures whether a translation is fluent regardless of the correct meaning. We use a 5-level scale to evaluate the fluency in Chinese, considering that the original words or phrases in the target language provide more fluency. We make one dimension as to whether the original Chinese word or phrases are included. Moreover, less semantic splitting provides greater fluency because the more similar the modification relationship among Hanzi, the more likely they are not to be split. So another dimension we consider is the number of semantic splits. In addition, a missing is considered for the semantic orientation of subtokens, which is a result of semantic split. If there are subtokens in the opposite emotion, the fluency score will be decreased by 1. Inadequacy of pronunciation and meaning dimensions. Adequacy measures whether the translation conveys the correct pronunciation or meaning. In this study, we use a 3-level scale to measure translation performance with respect to both pronunciation and meaning because there is no necessary to subdivide further. In the adequacy of the pronunciation dimension, we also consider that the similarity of the number of syllables, because the similar length of the pronunciation between source and target should be rewarded. And the adequacy of meaning, we consider it being short as a criterion because short meaning are easy to remember, which is essential for a business name. Table 1 shows how we evaluate company name translations with respect to the fluency dimension. Original indicates that there is at least one original Chinese word or phrases in the Chinese NE with respect to the meaning dimension. Shortly denotes that the number of Hanzi is equal or less than 4. It should be noted that the name of people, place, and so on in the transliteration should also be evaluated with a high score in the literal translation, because they also contribute to the meaning, and we ignore certain common words that do not contribute to the translation of business names, such as Inc., corporation, and group. Here are some examples of annotation. Since the translation of Celanese doesn't include the original Chinese word or phrases, only for independent Hanzi, we give 1 score in fluency. Since the pronunciation and the number of the syllables are similar in source and target, we give 5 scores in pronunciation. Oppositely, it gets 1 score in meaning. As for Apple Inc., after ignoring Inc. and corresponding translation, the translation of Apple, 苹果, is the original Chinese word, can't be split anymore, so it gets 5 scores in fluency. And as it literally translated and the translation includes 4 Hanzi, we give 1 score in pronunciation and 5 scores in meaning. Because some criteria are subjective, we calculate the agreement between annotators to ensure the annotations are available. We use Kuhn-Kappas coefficient to indicate the similarity of annotations from 2 annotators. First, we use the confusion matrix to represent the annotations from 2 annotators, and Table 2 shows an example of the confusion matrix of annotations on a 3-level scale, where A1 and A2 are scores from annotator 1 and 2, and the content denotes the number of items for each score. Then we calculate the kappa coefficient with equation 1, where the PO is the relative observed agreement among annotators, and PE is the hypothetical probability of chance agreement, using the observed data to calculate the probabilities of each observer randomly seen in each category. The result is shown in Table 3, where F, P, and M represent fluency, pronunciation, and meaning respectively. The kappa coefficient larger than 0.6 indicates that our interpreter reliability is substantial. Baseline model. In this section, I would like to describe a baseline model for character-based NE translation and propose filters to remove noisy samples from the wiki title dataset, and this demonstrates that the synthesized data could improve the performance of the model. We employed Badenoch et al.'s model as our baseline model for English-Chinese NE translation, which is an attention-based encoder-decoder model. The encoder of our model has 2 layers with 256 hidden dimensions. Therefore, the bidirectional GRU has a dimension of 512, and the decoder GRU states has dimension of 256. The input word embedding and output vector size are 256. For the dataset, we train and validate our models on the subset of the Wikititle dataset from which parallel entities are removed, and evaluate them on Wikititle competent dataset. Further, we train and evaluated our models on centralized data, that is, data from which the samples satisfying any of the following four conditions were removed. First, English and Chinese names are identical. Second, the Chinese name doesn't contain Hanzi. And third, English name contains Hanzi. And fourth, English or Chinese name is longer than 50 or 20 characters respectively. Table 4 represents the statistic of the resulting training and validation set data. All entities in both English and Chinese are split into characters, and the space is replaced with a special token. The vocabularies are built with all words from the original and synchronized training data. The general performance of a model is shown in Table 5. We use corpus level BLEU-4 and CHAR-F4 scores. We trained 3 models with different seed and use their average BLEU scores with error range to represent the final BLEU score on the test set. It can be observed that our baseline system achieved a reasonable performance that approximates 50 BLEU scores on the validation set, but failed to translate most entities in the test set that lower than 20 BLEU scores. The poor performance of our model is attributed to the fact that Wikititle's dataset contains highly diverse data, whereas the test set includes only competent names. Therefore, it is difficult to train an NE translation model and generate new competent names. Another potential reason is that the Wikititle dataset contains noisy data. The result obtained for models trained on centralized data supports these ideas and reflect a substantial improvement obtained using 4 simple rule-based filters, which increased about 10 BLEU score. Further, we manually annotated 338 outputs of the model trained with centralized data using the criteria introduced previously. Figure 3 depicts the correlation between the BLEU score and human evaluation scores, and the darkness of points denotes the level of overlap, where we use the sentence level BLEU-4 score as the BLEU score for each translation item. We set F plus F, max P and M as the human evaluation scores. Here, considering that the certain NEs are translated using hybrid methods, max P and M is used to balance the weight from transliteration and literal translation. The Pearson correlation coefficient of BLEU and human evaluation score is calculated as approximately 0.12. Both Figure 3 and Pearson correlation coefficient indicate that there is nearly no correlation between these two scores. The reason for the low correlation is that most of the translation obtains a BLEU score of 0, but different human evaluation scores. In the present test set, certain NE translations are not similar to the reference, but could be evaluated by human as being effective. Similarity with reference does not represent the quantity of NE translations. Table 6 presents translation examples generated by the model trained on the synchronized data. The reference NE of Zoetis is shortened, where our model transliterated it to Zoetis and makes a high pronunciation score. It obtains a low fluency score because there is no original Chinese word. For the NE Vipro, our model translated it with a homophone as a transliteration of people's names. It obtained high pronunciation and meaning scores. Conclusion. In this paper, we describe a new task for NE translation from English to Chinese. For this purpose, we present the human evaluation criteria for business names and build a test set, and the test set will be released. Further, we found that the correlation between the BLEU score and human evaluation scores is weak. The reason is that while the human evaluation score represents the quantity of NE translation, BLEU score represents the similarity between the reference NEs and the output from the model. Thus, we conclude that for evaluating NE translations, Reference-less methods should be more effective than reference-based methods. Okay, that's all. Thank you for listening.